Hi, welcome to our discussion on how to convert between distance versus time graphs to velocity versus time graphs. As we talk about this topic, we'll start with linear distance versus time graphs and convert them, and then we'll go to curved distance versus time graphs and convert those as well. So let's get started with linear ones. So we're going to take this distance versus time graph, and we're going to transfer it over to this velocity versus time graph. So instead of charting where it is, its distance or its position every second, we're going to be charting its velocity each second. So these two graphs are going to look quite different, so don't be alarmed, but they should because this one is talking about distance and this one velocity. So let's get started. One of the first things I like to do is just take a look at the distance versus time graph and kind of get my bearings. First of all, I notice that they're all these straight line segments. That means during each of these time segments, the object was moving at a constant velocity. I also noticed right away that there's going to be a positive velocity here, a positive velocity here, zero velocity here, so I'll put that one in, 0 meters per second, and then a negative velocity here. I can also tell that this one's going to be steeper, so it's faster here, kind of a medium forward here, and then a super fast backwards here. Look how super steep that is. It'd be really hard to stand on a hill this steep. Okay? So let's start doing some calculations. Before we can switch from distance to velocity, we got to first know the velocities. So you'll notice in this first segment, starts at 0 seconds, goes to 2, for a total of 2 seconds. And it starts at 0 meters, and we move forward to 10 meters for a total change in distance of 10 meters. And if I'm going to travel 10 meters in 2 seconds, I better be going at a positive 5 meters per second so I can get the 10 meters in 2 seconds. So that's the first segment. The next one you can see we start at 2 seconds here and we end at 4 seconds here for a total change in time of 2 seconds. And we started at 10 meters here and we ended at 14 meters here for a total change of 4 meters. Now if I'm going to go 4 meters in 2 seconds, well gosh, I better be going at a velocity of 2 meters per second to get to 4 meters in 2 seconds. Now the next one's already done for us, 0 meters per second. That was a straightforward one. And now this next one, I go from 5 seconds to 6 seconds. That's a total change of 1 second. And I started at 14 meters here, and I went backwards, losing distance down to 0 meters. That gives me a negative 14 meters of a change. Now if I'm going to change by 14 meters in 1 second, I'm going to need to be going negative 14 meters per second. Okay? So now I have my 4 velocities. For the first 2 seconds, I'm at a constant 5 meters per second. Then for the next 2 seconds, I'm at a constant 2 meters per second. Then for the next second, I'm at 0 meters per second. Then for the final second, I'm down at negative 14 meters per second for a second. All right, let's graph these. So our first 2 seconds, we spend at 5 meters per second. So on my velocity graph, I go up to what's 5 meters per second here. And I stay at a constant 5 meters per second for 2 seconds. Now at this point right here, I very suddenly decrease my velocity to 2 meters per second and then stay at a constant 2 meters per second during the next 2 seconds. So to show that very fast decrease, I'm going to drop my line straight down here to 2 meters per second. And you might even put a tiny bit of slope in this thing moving forward because you can't actually change your velocity instantaneously. There's going to be some small amount of time here. And then I'm going to move this forward at 2 meters per second to right there. So notice how these are lining up. This time that it took me to go 5 meters per second is the time right here, 5 meters per second. And then this next 2 seconds that took me 2 meters per second is right here. Now the next second I'm going 0 meters per second, so I very suddenly slow down to 0 meters per second, and then I head over for 1 second. And then very quickly right here, almost instantly, I speed up to negative 14 meters per second, but I speed up backwards, right? So I come down here, I drop down to negative 14 meters per second, and I stay there for 1 full second. That is my velocity graph from this distance graph. So constant 5 meters per second, slowed down 2 meters per second constant, slowed down 0 meters per second, sped up to negative 14 meters per second, but of course I was speeding up backwards here. All right, so this graph's a little more complicated. Notice that there's more segments and there's several more negatives. So we'll just take it step by step though. So we notice in this first step that we're going 0 meters per second. In this next segment, we're going to be going at a positive velocity, negative velocity, positive because we're gaining distance again, and then negative and negative. So let's go ahead and calculate the velocities in each of these segments. So we start here at 1 second, and this segment ends at 2 seconds for a total change of 1 second. We start at 6 meters, and we walk forward to the 14 meter mark. So that's a change in distance of 8 meters, which means, of course, our velocity must be a positive 8 meters per second. The next time interval, we start at 2 seconds, and we go over to 2.5 seconds. So that's a total change of 0.5 seconds. And we started at 14 meters, and we went backwards to 8 meters. So that's going to be a change in distance of 6 meters. And if I'm going to go 6 meters in half a second, I've actually have to be going 12 meters per second, so I can cover 6 meters in only half a second, and of course that's negative. Let's do the next segment. So in this one we start at 2.5 seconds, we end at 4.5 seconds, a change in time of 2 seconds. We started at 8 meters, and we went forward to 12 meters, so a change in distance of 4 meters. Now, if I'm going to go 4 meters in 2 seconds, well, I better be moving at a positive 2 meters per second. So in this one, I start at 4.5 seconds. I end at 5 seconds. So again, here this is 0.5 seconds. We start up here at 12 meters, and we come down here to 4 meters. So that's a change in distance of negative 8 meters because I'm losing distance here. And if I'm going to go 8 meters in only half a second, I have to be moving at 16 meters per second in order to get to 8 meters in half a second. Of course, you can just divide these as well, distance divided by time, and you'll get 16. All right, last segment, and then we'll start doing some other work. In this one, you go from 5 seconds to 6 seconds, a total change of 1 second. You go from 4 meters to 0, a negative 4 meter change. And of course, that's negative 4 meters per second. Now we just need to take these velocities in all these segments and graph them onto our velocity graph. So notice we start out here for our first second, we're going 0 meters per second. So I'm going to come down here to 0 meters per second and just go over for 1 second. Notice how those segments line up. Now for our next segment, we're going 8 meters per second. So on here, 8 meters per second. So I'm going to jump up from 0 meters per second very suddenly to 8 meters per second right there. So I'm going to jump straight up to 8 meters per second. In reality, there should be a little bit of slope there. And then I'm going to stay at this 8 meters per second for 1 second. So I'm going to head over to 1 full second worth. And then I'm going to jump down very suddenly here. Notice this huge change. Very suddenly, I'm going to jump down to a negative 12 meters per second. And this is a big jump down because then you can tell that from the graph above because look at the huge change in slope, right? There's a very sharp point there. So that's a big change down. And I'm going to hold that for half a second at negative 12 meters per second, right to there. Now at this point, another sharp point, I'm going to jump from negative 12 meters per second to 2 meters per second. Come up here to 2 meters per second, and I'm going to hold that for a full 2 seconds, so all the way over to the 4.5 second mark. Right. And at that point, I'm going to take a very sudden jump. Oops, that should be negative, my apologies. A very sudden jump from positive 2 down to negative 16. So again, it's a big jump because it's such a sharp point there. Very sudden change in velocity. Down to negative 16, I'm going to stay there for half a second. And then I'm going to jump up to negative 4 meters per second. And then I'm going to stay there for a full second. You'll also notice a trend. Any line with slope on a distance versus time graph, a straight line with slope, turns into a horizontal line on a velocity time graph. So let's write some of this down. On a distance versus time graph, any line with slope on this graph turns into a horizontal line. Now let's take a brief look at curve distance versus time graphs and how to transfer those to velocity versus time graphs. These we're not going to do as numerically as the straight line ones. We're going to do them sort of qualitatively and just to get a feel for it. If this gets too much for you, don't worry. It's really at the edge of what our course is covering. So if you can really master this straight line distance to velocity graphs, you'll be doing great for your first year of physics. All right, so we're going to start this in the same way we started the straight lines one, just to get a feel for the graph. We can see here that we start out flat, so slow, and our slope gets steeper and steeper and steeper and steeper and steeper, so we're speeding up all through here. And right about here, we go from speeding up to slowing down. So here we start out steep, and we end less steep, less steep, less steep, stop. So this side is speeding up, and this one is slowing down. So those are two things, and they're both forward. So they're both positive velocities the entire time. All right. So now once we have that established, we can start drawing our velocity graph. So we know we're going to start out with a 0 velocity here. And we're going to increase that velocity. So it ends up looking something like this. Our velocity increases to right about there. And then our velocity at this point starts decreasing. This is the steepest part. Decrease, all the way back down to here is a 0 velocity. It's almost flat. So this line is going to then decrease back to 0. So that's drawing it. Now, to really get the shape of this may not be a line. It's likely to be a line for a lot of things in physics, but the idea here is that the velocity is increasing somehow. It may not exactly be this line, but it's increasing to this point and then decreasing beyond that point.